Welcome to Cosmic Compass, where we navigate the mysteries of the universe together. In this video, we're going to explore one of the most fascinating questions of our time. Why are nations and companies suddenly so interested in the moon? As more countries and companies set their sights on space, one question keeps coming up. What's the ultimate goal? Do we simply dream of becoming a spacefaring species, exploring for the betterment of humanity? Or as many suspect, do people smell profit in space? When we think of the moon, most of us picture a grey, barren world. But beneath its dusty surface lies a surprising wealth of resources. Some of them could change the future of energy technology and even global politics. Mining on the moon might sound like science fiction. Yet, in the next couple of decades, it could become a reality. Why? Because what's hidden in the lunar soil is more valuable than most of us realise. Let's explore together what's actually there and why nations and private companies are preparing for a new kind of space race, one not for land, but for resources. The first substance worth mentioning is helium-3. You may have heard of it in science fiction, often portrayed as the perfect fuel for a new kind of nuclear reactor. In theory, helium-3 could allow for fusion power that produces no dangerous radiation, no toxic byproducts, essentially clean, limitless energy. It also has specialized uses in medicine and radiation detection. On Earth, however, helium-3 is extremely rare. It exists in trace amounts in natural gas, around 100 parts per billion. To put that into perspective, if we had 1 billion cubic meters of natural gas, we'd only extract about 15 kilograms of helium-3. That's not economically viable. Another way to produce it is from the decay of tritium, but tritium is tied to nuclear weapons. As global stockpiles of weapons decreased, so did the production of helium-3. So, where do we find more? Without fueling nuclear proliferation, fortunately, we have a world in orbit around Earth that has been bombarded with helium-3 for billions of years. The moon, unlike Earth, which has a magnetic field to deflect solar wind, the moon simply absorbs it into its upper soil, the regolith. The concentration isn't huge, about 50 parts per billion, but it is spread across the entire surface. That means it could be collected as part of any large-scale mining operation. China has already stated that helium-3 is one of the primary goals of their lunar exploration program. American, European, Russian, and Indian scientists have all discussed its potential, and private companies are interested too. If fusion technology advances, helium-3 could be the key, and the moon might be our best supply. Helium-3 isn't the only thing hidden in the lunar regolith. This dusty layer is packed with other minerals and metals. False colour maps of the moon reveal deposits of iron, titanium, aluminum, silicon, calcium, and magnesium spread across the surface. Extracting these raw materials could be challenging, but there's a bonus: separating them often produces oxygen and hydrogen as byproducts. While those elements aren't rare on Earth, they could make all the difference for a lunar colony. Oxygen means breathable air, hydrogen can be turned into fuel, and together they make water. Even the unprocessed regolith itself could be useful. Scientists suggest turning it into lunarcrete, a building material for constructing habitats, landing pads, and infrastructure without hauling heavy supplies from Earth. It can also be melted into glass, another valuable resource for construction. And while lunar soil isn't ideal for agriculture experiments, show that some plants can grow in it with the right support supplementing hydroponic systems. Imagine breathing oxygen made from moon rocks, drinking water mined from the soil, and eating food grown in lunar greenhouses. These are the building blocks of a self-sustaining base. So the regolith isn't just dust, it's a resource kit for survival and expansion. Perhaps the most strategically important resources on the moon are the so-called rare earth elements. Despite the name, they're not especially rare in Earth's crust, but they are dispersed, making them extremely difficult to mine in concentrated amounts. On Earth, only a few countries have deposits large enough to extract. Even then, Mining rare earths is messy and polluting. The chemicals involved contaminate water and soil, and the process takes a heavy toll on human health. That's why most countries avoid large-scale rare earth mining altogether. The notable exception is China. With about 30% of the planet's supply and control of over 95% of the global rare earth market, China has positioned itself as the dominant force in these vital materials. Why are they so valuable? Because rare earths power modern technology. They're inside smartphones, wind turbines, advanced electronics, and especially batteries for electric vehicles. As the world pushes toward cleaner energy and electric transportation, demand for rare earths is skyrocketing. Now imagine if instead of tearing up Earth and polluting our own environment, we could mine these elements on the moon. Lunar rare earths aren't more common than Earth's, but some deposits have already been identified, and extracting them on the moon would avoid the environmental destruction here at home. Control over these materials means control over prices, and by extension influence over global industries. If one nation were to dominate lunar rare earth mining, it could reshape the balance of power. Will China extend its current dominance to the moon, or will the US, Europe, India, or private companies try to secure a share? That's the looming question in this new resource race. With so much at stake, there's an obvious question: who has the right to mine the moon? The answer, at least for now, is unclear. The main international agreement is the Outer Space Treaty, signed by most spacefaring nations. It prohibits weapons of mass destruction in space bands, military bases on celestial bodies, and prevents any nation from claiming sovereignty over the moon or other planets. But here's the catch: it doesn't explicitly cover resource extraction. Other treaties have been proposed to regulate space mining, but only a handful of non-spacefaring countries have signed them. Major powers have avoided committing to anything that might limit their future opportunities. That leaves us in a legal grey zone. If mining begins, it may come down to a first-come, first-served principle. Whoever has the technology and the will to start digging might set the precedent for everyone else. This uncertainty could spark competition and even conflict. Just as oil shaped geopolitics on Earth, lunar resources might do the same in space. The question isn't just whether we can mine the moon, it's whether we can agree on how to share it. So what have we learned? The moon, far from being a lifeless rock, holds resources with the power to transform our future. Helium-3 could revolutionize energy. Regolith could sustain colonies. Rare earths could secure technological dominance. But these opportunities come with challenges. Mining on the moon would be costly, dangerous, and technologically complex. The legal framework is unclear, and the race for resources could just as easily lead to rivalry as to cooperation. Still, the potential is too great to ignore. The next great resource race may not unfold on Earth, but 380,000 kilometers above it. Will mining the moon be the solution to humanity's growing needs, or just an expensive dream? Only time will tell. For now, we can say this: the moon is no longer just a symbol of exploration. It may be the next frontier of survival, power, and profit, and the race to claim its treasures has already begun. The moon may look quiet from Earth, but as we've seen, it could hold the keys to humanity's future in energy, technology, and survival beyond our planet. Mining the moon might sound like science fiction, but the race has already begun. Who will succeed, and at what cost? Those are questions only the future can answer. If you enjoyed this journey, make sure to subscribe to Cosmic Compass so you won't miss our next deep dive into the cosmos. Together, let's keep exploring the universe one story at a time.